Hi there, and welcome to another lesson in quantitative reasoning, in which we're going to cover the concepts of estimation and time-saving techniques. Now, arguably, these are the two most important things you can grasp for quantitative reasoning. It's a very time-intensive section, and anything we can do to save time is going to be worthwhile here. So, we're going to aim to cover 4 different things today. We're first going to go over the difference between what we mean by estimation versus precision. We're of course going to have to link that into graphs, so we're going to talk about eyeballing graphs. Then we're going to go over underestimate versus overestimate, which is a technique you have to use when you do an estimate. And then finally, we're going to talk about checking your answer, using the skills of estimation and when we should really do that. So let's think about what the definition between, or what the disparity between estimation and precision actually is. So when we estimate something, we're making a guess fundamentally. We're being very flippant with what maths we use. We'll use mental maths where possible. It's going to be a lot quicker though. Whereas when we work precisely, we're going to be using exact numbers to get exact answers with exact accuracy. So that's the fundamental difference between what we mean by estimation and precision. And both have parts to play in the UCAT. So this is what we're going to talk about today. When do we use either of them? So in order to get a grasp of what your current instinct is and how you currently do questions, I want you to pause the video and have a go of this one, just however you would normally have attempted it. So pause the video now and have a go. So I want you to quickly reflect, what was your method for doing that one? If you went and grabbed the calculator and did the exact maths for that one, that's absolutely okay. This is what we would expect many people to do at this point. So you would be doing 580.72 divided by that 122. It would have taken you probably around about 30 seconds to do that in the actual UCAT with the pesky calculator that we have going on. However, if you were one of the few students that actually did estimate this one and think, okay, those numbers are close enough to 600 and 120, so I'm just going to estimate and do 600 divided by 120 to get 5. Option B is close enough to 5. And then pick that one. You would have done that a lot quicker, and that's going to be the person who gets a higher score in quantitative reasoning. Someone who understands when we can actually estimate questions. So let's talk about why we would use estimation. We know it seems to be the better method for some questions, but why is it the better method? Well, fundamentally, if we're to round the answers, we're going to be able to use those answers a lot quicker. And we're actually going to be able to do mental maths for those ones. And mental maths is going to be far quicker than whipping out that calculator. Estimation also covers the concept of inspection or eyeballing, which is just where you can answer simply based on looking at the numbers and not really doing any maths involved there. So that's what the benefits of estimation are. Of course, on the other hand, we have precision, which equally has benefits. So when we do work precisely, our main benefits is the ability for us to get that exact answer. We will not have any error in our answer. It will be precise. And that can really help when we're worried about making mistakes due to inaccuracy. So whenever we think that making a small rounding error may actually affect our answer, precision clearly has the benefit here. So now that we know the benefits of both estimation and precision, let's talk about why we would do either of them. So when we think of estimation, we're going to be looking at our answer options first. If our answer options are all spread out, if there's a big gap in between each of the answer options, as there is with these ones here, it's going to be safe to estimate, because even if we get that approximate answer, we're going to be landing close enough to one of them. On the contrary, we can look at the actual question, not the options, but the question, because sometimes there are actually trigger words there. This one contains the word approximate, which would be so easy to miss in the UCAT. But if we do look at that trigger word there, it actually tells us to estimate. And finally, if we have something that is going to be a long and complex and sort of difficult calculation, there's probably going to be a way to estimate, because the UCAT consortium are never going to give you something that would be absolutely impossible to do in 40 seconds. And they're not going to ask you to just punch endless numbers into a calculator, because that's not really testing anything. So on the other hand, when do we work precisely? Well, it's fundamentally the reverse. So with this one, you can see the answer options are incredibly close together. They're only a penny apart each time. If we estimate and we get ever so slightly off, we're going to be jumping from one answer bracket to the other, and we can't be doing that if we want to get the right answer. Additionally, there's a trigger word in this one as well, which hopefully you'll have picked up this time. So the word exact sort of just hints to us, maybe we shouldn't be as flippantly estimating this time. Maybe we should get our calculator out. So those are sort of the ways that you can figure out whether you're going to be estimating or working precisely. So always look at your answer options, look at the question, and think about what's actually being asked of you. So one of the ways that I absolutely love to use estimation is with graphs, and we call that eyeballing graphs. So I want you to, without sort of thinking about how you're going to do it, pause the video now and again, try it with what your instinct would be, and then come back and we'll talk through it together. So the important thing with graphs is that we can only work to the precision that they give us. Now this is a very poor graph. There is absolutely no accuracy on that y-axis there. We struggle to tell what those bars actually represent. So you would not be expected to figure out that, China is exactly 787. Like you wouldn't have any way of knowing that. So always work to the accuracy that you're given. If you're given a graph that we cannot get a precise number from, then we can almost be assured that we're going to have to estimate this one. So this is absolutely one that we can estimate, and you can hopefully see that the answer options are spread out as well. So we're going to be able to do some estimation here. So we're looking for the difference of Russia to Japan. So what I'm going to do is literally just think about where those bars line up. I'm just going to be very inaccurate with it and just very estimating. I'm going to draw a line on just so you can see what my logic is. So I'm just going to go, Russia is like roughly about 400 there, let's say that. And then we've got Japan here, and Japan down the bottom is probably about, let's say 200. So we've got 400 to 200. 200 is going to be our answer option. So if you did say 200, well done. But remember, you didn't need to do any accuracy there. We could just eyeball that and have a rough look at what the difference is. Now, it's worthwhile saying just when we're halfway through that while estimation is an awesome skill and it's such a time-saving skill, we always need to make sure that we know we can estimate before we just jump in there and try. You don't want to be estimating blindly each time. If we are sort of point blank estimating for every single question, you're bound to make mistakes. So always sit back first and think, can I estimate here? And if you can, then go for it. But if not, don't worry, there's lots of questions that you won't be able to, and you will have to work precisely. So always just bear in mind to ask yourself, can I actually estimate before you do? So here's another graph. Hopefully you can see the similarities to the previous graph with a very inaccurate y-axis. So I want you to pause the video now, give this one a go, and come back when you're ready to go over the answer together. So for this one, what the question is actually asking us to do is basically add up all of those grey columns and then minus the total of all of those red columns. Now that is a lot of tedious maths that really we don't have time for in the UCAT. So what we're going to do is look for any sort of shortcut that could get us the total of those grey columns and the total of those red columns without doing much maths. So if we think about how to get the total of a certain number of things, we could just take the average and times it by 8. It's because there's 8 columns here. Now this is an example of when we're going to have to work to the accuracy of the data that we're given. Now this isn't very accurate data, so looking at the rough average of those grey columns, I'm going to say it's roughly 1,000. We've got a couple below, a couple above. So let's throw in 1,000 there. So we're going to say the total of the grey columns is going to be 1,000 times by that 8, which is going to be 8,000. Next thing we're going to do is then think of the total of those reds there. So I think the average for those reds is probably going to be, I'm going to say below 200, so maybe about 150. So let's do 150 times 8, and that's going to equal 1,200. So then taking the subtraction of that, the difference between those, that's going to get me to 6,800. Now 6,800 isn't one of my answer options, but I've got to remember that I have estimated here quite a large amount. So I'm going to go with the one that's closest to 6,800, which of course in this case is answer option B, 7,530. If you had perhaps estimated to 1,100 for your grey columns, this would work a bit nicer, but even if we didn't and you did what I did, we would still get to the right answer. So well done if you did manage to get B without doing much maths. So as you saw with that previous one, if we were to work precisely, we would be having to do a lot of maths. You'd have to punch 16 different numbers into your calculator. There is no way that the UCAT consortium are going to ask you to do this. As I said before, it's not going to show any skills. What they are going to want you to do is find a shortcut to it. So anytime you're faced with a long-winded or a number-heavy question, always try and take a step back and look for some sort of shortcut to estimating. The more you practice and the more you always look for these shortcuts, the easier they're going to be to spot. Now, with that question, some of you may wondered that, oh, well, we got an answer of 7,100, but the answer that we chose was 7,530. It's quite a big disparity, and I agree with you, that is a big disparity. What we had to be careful of there is whenever we sort of times an estimate upwards, we're just going to be extrapolating that margin for error. Now, this is particularly prominent in averages. Because averages are going to be timesing or dividing by a certain number, all you're doing is making that margin for error bigger. So just have this, at the back of your mind, that if you are going to be multiplying or taking the average of an estimate, you are going to get a bigger margin for error. So we have to be sure that our answer options allow us to actually do that. So something that we've not quite talked about yet is, how do we roughly know where our answer is going to end up if we're estimating? So let's have a look at this one here. Hopefully none of you would jump to immediately do this one on a calculator in an estimation lesson. So let's talk about how we're going to estimate this. I would say we can round this to 10 for that 9.8, 11 for that 11.1, and then 20 for that 19.7. 10 times 11 times 20, it's going to be 2,200. Awesome. So we've got 2,200. That is only close to one of our answer options, so we'd probably already be selecting C. But let's just talk about the theory behind what we've done. How have we rounded our numbers? So we've rounded that 9.8 up, haven't we? We've rounded it up very slightly. We've rounded that 11.1 down ever so slightly. And we've rounded that 9.7 up as well. So overall, most of our estimation has been upwards. So we've got up times down slightly times up. So our overall answer is going to be higher than we expect. That's what we call our answer being an overestimate. So look at how you've rounded your different options, and then you can get an idea of how your answer is going to look in comparison to the real and accurate answer. So here you can see that 2,200 is higher than answer option C, 2,143. Knowing that this is an overestimate gives us that little bit of reassurance that, okay, this is in the right direction. We're doing well. So we'd be more confident in order to select C here. Let's say that this question did come up in the UCAT. If you were to jump to your calculator for this sort of question, I wouldn't be, coming down on you too hard. This one would only take a few seconds to do on a calculator. It's understandable if you would want to do this one on a calculator in the UCAT. But the concept of estimation is something that you should always keep in mind for the longer and harder questions where you can't be doing your calculator every single question. So, as you just saw, we have our two types of estimate. We have our overestimate, and this is when the estimated answer is going to turn out higher than we expect. So an overestimate is as simple as if we're rounding sort of both of the multiplying factors upwards, then we're going to get an overestimate. Now, let's just talk briefly about fractions and divisions. So if you change the top of your fraction, it's just going to turn out the exact same. If we round up the top of our fraction, it's still going to end up being an overestimate. However, if we change the denominator of our fraction, as we do with this one here, we're rounding that 8.4 down. Because it's on the bottom of a fraction, overall, it does the sort of the opposite to your answer, just because it's on the bottom of the fraction. So you're rounding that figure of 8.4 down. Therefore, that is making your overall answer that you're going to get rounded up and higher. Just think of it as how many 8.4s can we fit into 80? If we make it slightly less, we're going to be able to fit more of those 8.4s into that 80. So it makes sense it's going to be an overestimate. And then of course on the flip side of overestimate, we have our underestimate, and underestimates work the exact same way. So if it's on the bottom of a fraction, the opposite happens. However, if it's just a simple multiplication, or an addition, then we just have rounded down, means it's going to be an underestimate overall, as we have with this one here. So estimation is absolutely a brilliant skill, but it cannot be used in isolation. It gets you a certain extent. So bearing that in mind, I want you to try this question just however you think it would work for you, and then come back and we will go through the answer together. So first thing I notice with this one is I'm going to be getting rid of some of that table. I've only got 5 answer options. I've got 8 pesky books lying around. So let's just score out the ones that we don't need at this point. So we're not going to need Lolita. We're not going to need Crime and Punishment. And we are also not going to need Gulag Archipelago. Fab. So those are our 3 out of the way. So don't do any calculations you don't need to. Awesome. So now let's talk about what we're actually going to do. So the question is asking us to find the difference between the first 2 columns. So let's just call that column 1 and column 2 for now. And we're going to call this third one the percentage. So column 3. So the overall sum that this question is asking you to do is 1 minus 2, and then you take the percentage of that third column. So we're doing 1 minus 2, then the percentage of that third column. So in order to do that difference between 1 minus 2, we should be able to estimate those numbers there. So let's start estimating those for all of the 5 books we have there. So the important thing that we're going to say first is I am not going to bother writing thousands down. I'm just going to have in my mind that anything I write is going to sort of be to the thousands. So like this. So I'm going to work out the difference. I'm just going to write diff for that in thousands. So for the first one there, I have a difference of 7,000. For Father and Sons, I have a difference of 4,000. Life of Avicum, 8. Master and the Margarita, 10. And War and Peace, 28. Awesome. So that's all my estimation done. Very sort of off the cuff. Don't need to do any big strenuous maths there. I just sort of looked at the first numbers of the thousands columns there. Grand. So now what do we do? Well, we're going to be now taking the percentage of that. And we're wanting the one that has the smallest difference. So we're looking for the smallest result of our red calculation there. So for that to be true, we're going to want the smallest percentages, aren't we? Well, the last 2 there, Master and Margarita and War and Peace, are quite big numbers in comparison to the others. So I'm going to bank those just now and sort of rule them out. So all I'm going to do is put a little line through these ones and say that I don't think it's going to be those for now. Hero of Our Time and Life of Avicum have similar estimations as 7 and 8, but the percentages are quite different. So since we're wanting a smaller percentage, I'm also going to rule out that Life of Avicum just now and say that it can't be that because there's a 20% difference. So now I'm stuck between those last 2 ones there. So I've either got, the 7 and 4, and I've got 2 different percentages. Now just in my mind, I can't work out the difference between those. So at this point, I would be plugging those into a calculator to get whatever comes out exactly. We probably wouldn't estimate too much at this point. I would still just take 11.9 times 7 and see what's going on there. And if we were to do that and pop those into our calculator, we would end up getting that Hero of Our Time is actually the smallest answer there. So you can see with that question, we estimated most of the way through, eliminated answer options as we go. We did end up having to work precisely, and that's okay. We still saved a lot of time by estimating as much as we can. So you may not even notice what I did on that last slide. So when I was writing out 7,000, I was knocking off all the zeros. There's no point in writing out more than you need to. So adapting your own sort of shorthand is so incredibly important for quantitative reasoning. You're going to have a limited space on the whiteboard and you don't have time to be jotting down all your calculations. Keep stuff in your head while you can, and there would be no need to write out all the sort of the sums and stuff that I did on the previous slide. That was just for demonstration. So remember to pay attention to what you're writing down, and fundamentally don't write down anything that you don't need to. We don't have the time to waste there. So sometimes we will fill ourselves with doubt in the exam, and that's natural. It's a stressful exam, and of course we're going to second guess ourselves all the time. Don't let this get the better of you. Know that you can take a few seconds and do a sense check, just do a quick calculation in order to put your mind at rest. So let's look back at this one, which you'll recognise that we just did. So some of you may have worried with this previous question, why did I rule out War and Peace so flippantly? And that's because sort of in my mind, I had already done a brief estimation. So the low percentage may have dragged some of you to this one, the 15.5% in comparison to all the others. Whereas I had sort of immediately just thought, okay, what is 15% of 30,000? It's going to be 4,500, which is already higher than our 800. And our 800 for the previous ones, we're then going to be taking the percentage off and making it even smaller. So that quick sense check could help put your mind at rest. So if you're doubting something, do a quick estimation and just put your mind at ease for it. It will be worthwhile when you come out of the exam feeling that bit less anxious. So with many of the answer options, you'll get your answer and it'll match one of the options and you're like, yes, got it. I hate to be the downer in your boat just now, but the UCAT know that there are certain wrong steps that people will commonly take. So if you end up taking one of these wrong steps, you may actually pick an answer that they have designed in order to throw you off. So the general takeaway rule from this is just because your answer matches one of the answer options available does not necessarily mean that it's right. It's always worth just doing a sense check, doing an estimation if you can, over versus underestimate, just to make sure that you are in the right ballpark. So the other thing to mention, and we'll talk about this more in our reading question stems tutorial, is that I straight away sort of ruled out the lines of those tables that I didn't need. I comprehended what I did need and what maths I had to do with the different rows and columns. Now this is something that you should do immediately when you're presented with a large table. So there's going to be info in there that's meant to distract you. So take a moment, understand what data you need and what data you don't, and try and hone in and focus on just what you're required to know. So let's go over our take-home messages for today. So hopefully one of the first things that you'll have noticed is that we covered what estimation is, when we can estimate and why we would estimate. On the contrast, we also worked out when you would work precisely and why you would work precisely. We then looked at graphs and specifics and talked about eyeballing graphs. Eyeballing graphs is a very important technique, so make sure you have your head grasped around that one. We also looked at what it's like to do an over versus underestimate and why this can come in useful for just checking our answer. We then briefly touched on elimination. Now bear in mind, elimination has an entire tutorial on itself in our quantitative reasoning course. So there's plenty more to come on elimination. And then finally, we just went over checking your answer. So everything from a sense check to knowing that UCAT consortium are sneaky and put in answers that are there to trip you up. So congratulations on completing another lesson, and I look forward to seeing you again for the next one.